This is the second lesson of Unit 2. So we are going to be talking about the parabola here. So you should remember from the last lesson that parabola is formed when we have a quadratic relation. So this is the graph of a quadratic relation, and what we call it is a parabola. So the parabola has some important features. So I'm going to start down here. So we know that the lowest or the highest point, again, we learned this in the last lesson, is what we call the vertex. Okay, and that vertex is going to have, it's going to be a set of coordinates. So it's going to have an x coordinate and a y coordinate. This line here, this dotted line, represents the optimal value. Okay, which is just the y value of the vertex. Y value of the vertex. Okay, the x value of the vertex, which is pointing to this other dotted line here, is what we call the axis of symmetry. Which again is that x value of the vertex. Okay, a couple other things we have. We have our zeros. Okay, so these zeros have a couple different names. So you might also hear me call them the x-intercepts. Okay, which is where our parabola crosses the x-axis. And I will also potentially refer to them as the roots. Oops. So those are all interchangeable. But basically it's when our x equals 0. Okay, and then the last thing here, we can see that our parabola at this point is crossing the y-axis, so that's what we call the y-intercept. All right. So moving on, everything you ever wanted to know about parabolas. So our parabolas can open up or down. Okay, the 0 of the parabola is where the graph crosses the x-axis. Crosses the x-axis. And we saw that on our sketch above. As I also said above, zeros can also be called x-intercepts or roots. Okay, the axis of symmetry divides the parabola into two equal halves, so it makes it symmetrical, right? That's why it's called the axis of symmetry. The vertex of the parabola is the point where the axis of symmetry and the parabola meet. Okay, it's the point where the parabola is at its maximum or minimum value. The optimal value, on the other hand, is the value of the y-coordinate of the vertex. And lastly, the y-intercept of the parabola is where the graph crosses that y-axis. Okay, so for this part of the note, all we did is we labeled our parabola, and then we expanded a bit on each of those things, what they actually mean in the bottom half there. So this is a quick note. We're already halfway done. So we have one more page. Okay. So analyzing parabolas. So it says for the following parabolas, fill in the table with which follows. So fill in this table based on those images of the parabolas. So let's just start. Let's fill in that first column. So looking at this parabola, the parabola is obviously that blue line that we're seeing. So it's asking us what is the vertex. So remember, the vertex is the lowest or highest point on my graph. So in this case, because I'm opening up, my vertex is this point here. Okay, so we just need to look at our graph to figure out the coordinates. So remember, the x-coordinate is always first, so I look at my x-axis. On my x-axis, I am at 3, and on my y-axis, I am at 1. Okay, so 3, 1 is the coordinate point of my vertex. The optimal value, remember that is your y-coordinate of your vertex. So your optimal value here is y equals 1. The axis of symmetry is your x-coordinate of your vertex. So that is just x equals 3. Okay, it's asking for our zeros. So remember, our zeros are where we cross that x-axis. The x-axis, is this line here, right? That line that I just kind of highlighted. So as we can see, our graph of that parabola is never crossing that x-axis, so we don't have any zeros. So we're just going to put none. Direction of opening. So again, we're just looking, is this opening up? Does this have a lowest point, or is this opening down? Does it have a highest point? So this one we can see is opening up. And the last question here is, what is our y-intercept? So again, from that first page, you should know your y-intercept is where you're crossing that y-axis. So that point is going to be right in here. So it's between 6 and 7. So we're going to say that it's at 6.5. When we're writing our intercepts, we're writing them as a coordinate point. So this is going to be 0, 6.5. And again, it's 0 because our x equals 0. Our y-intercepts are always going to have x-coordinate 0. On the other hand, our zeros, or our y-intercepts, are going to have y-intercept 0. Okay, and that makes sense if you look at your graph. Okay, let's move on to this next one. So again, it's asking us for the vertex. So we're looking for the lowest or the highest point. Here, again, we have a lowest point, and that's going to be approximately here. So we look at our x-axis first. So that coordinate is -1. And our y-coordinate is -4. Okay, again, once we know the vertex, we know the optimal value, and we know the axis of symmetry. Optimal value is just our y-coordinate of that vertex. Axis of symmetry is our x-coordinate of that vertex. Zeros. So we're looking, where does this cross the x-axis? So this one actually does cross, unlike the other one, right? We see it crosses here, and it crosses here. So we just need to write out those coordinate points. So the first, these are x coordinates. So we look at our x first. Our x, looking at the right-hand side here. So this we have 1, 0. And our second one we have -3, 0. Okay, direction of opening. Again here, it looks similar to the first one. We're opening up. And our y-intercept, again, that's where our parabola crosses the y-axis. So it's going to be there. So that is going to be at 0, -3. Okay, one more example here. So again, the vertex highest or lowest point. So this one's going to be a highest point, which differs from the last two. So you can see where I kind of made a line there. So looking at our x first, so we have -3. We're going over -3 and up 5. So our coordinate is -3, 5. Again, our optimal value is just our y-coordinate of that vertex. Our axis of symmetry is just our x-coordinate. Now we're looking where we cross that x-intercept. So this one isn't perfect, but we'll just assume it's shifted a little just to make it easier for us. We'll assume that it's on those lines. So this crosses at -1, 0, and -5, 0. Okay, what way are we opening? Well, as you can see, we have a highest point here, so we're opening down. And do we cross the y-axis? We do. We cross at approximately this point, so that coordinate would be 0, -4. So you should be able to look at a graph and come up with all of this information just simply from that graph. All right, so we're finishing off with some true or false. So we're going to use the above here to answer those questions. So it says the axis of symmetry goes through the y-intercept. So let's look here. So remember, our axis of symmetry is our x-coordinate of the vertex. So if we drew that line, it would look something like this, something like this, something like this. And we can see that absolutely does not go through our y-intercept, right? So that is false. Next question says the vertex is always located halfway between the zeros. So let's look at this one. So remember, our zeros are where we cross that x-axis. So if we count over to the middle there from this one, so we go 1, 2, and we're at the middle. From this side, 1, 2, and we're at the middle. Okay, so it's true for that one. Let's double check this one here. 1, 2, middle, 1, 2, middle. So that is true. The vertex is always halfway between those zeros. Okay, the next one. The y-coordinate of the vertex is always the same as the optimal value. So the y-coordinate of the vertex is always the same as the optimal value. As we can see, that is also true. A parabola must always have at least one x-intercept. Well, we can see from this one here, where we said there wasn't any, that has to be false, right? It doesn't always have one x-intercept, and these two here have two, right? So we know that that's not true. The x-coordinate of the vertex is always the same as the axis of symmetry. So we can see x-coordinate of the vertex, axis of symmetry, x-coordinate, axis of symmetry, x-coordinate, axis of symmetry. We can see that, yes, those are all the same, so that is true. A parabola must open up. We can see from that last example that we did that that is not true, right? A parabola can open up or down, so that is false. And lastly, the y-intercept is always positive. So again, we're looking at this last column here. So y-intercept, we can see that that is negative and that is negative. So obviously our y-intercept does not need to be positive. That is false. Okay, and this is the end of the note on introducing parabolas.